Chapter 2, Section 6, Proving Angles Congruent. So there's my puppy. She's just blocking the rest of the proof. So proof of theorem 2-1, that vertical angles are congruent. So they're giving us that angle 1 and angle 3 are vertical angles. Then they're asking us to prove that they're congruent. So we're assuming that we've never seen this theorem before and we need to prove that they're congruent. Well, let's just come up with a plan of action first. In the future, it will be given to you, let's say that this is line AB, and this is line CD. It will also be given that CD is a line, and AB is a line, so if you just want to fill that in. Because you need to know they're a line so that you can show that angle 1 and angle 2 are supplementary because they add up to a line. They're a linear pair. So, just to start out, angle 1 and angle 3 are vertical angles. Usually you start with the given statement, but you don't always have to. Now we said angle 1 and angle 2 are supplementary, and we also know angle 2 and angle 3 are supplementary because angles that form a linear pair are supplementary. Now, since we know that they're supplementary, we can say that they add up to 180. So the measure of angle 1, notice that you're saying the measure of because we're adding and we're setting it equal to. The sum of the measures of supplementary angles is 180 degrees. Now from here, let's say since they're both equal to 180, since A equals B and B equals C, or since, let's say, measure of angle 1 plus angle 2 is our A and 180 is our B, then B equals C. That means the measure of angle 1 plus the measure of angle 2 must equal the measure of angle 2 plus the measure of angle 3 by the transitive property of equality. Now, if we simply subtract the measure of angle 2 from both sides, it cancels out on both sides by the subtraction property of equality. So we have the measure of angle 1 equals the measure of angle 3. You have to change them to congruent because we're trying to prove that they're congruent, not that they're equal. So the angle 1 is congruent to angle 3 because angles with the same measure are congruent. And that would be the end of our proof. Let's try this. So it's given that angle 1 is congruent to angle 4. So angle 1 is congruent to angle 4. We want to prove that angle 2 is then congruent to angle 3. So let's start with what we've been given. Angle 1 is congruent to angle 4. Now we've already proven that vertical angles are congruent, so we can use that here. So that means that angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2 because they're vertical angles. So let's state that. Angle 4 is congruent to angle 2 because vertical angles are congruent. And we know that angle 4 is congruent to angle 1. Here we're not switching to equality. You can switch back and forth between equality and congruence, but you have to have a reason each time. So here we're just going to state by transitivity of congruence. So angle 1 is congruent to angle 2 by the transitive property of congruence instead of equality because we're working with congruence. Then we can say that angle 1 must be congruent to angle 3 because we said before they're vertical angles, and vertical angles are congruent, which means angle 2 must be congruent to angle 3 by the transitive property of congruence. So again, it was given that 1 is congruent to 4 here. Then since 4 and 2 are vertical, they're congruent. So then we can use transitivity to prove 1 and 2 are congruent. Then 1 and 3 are vertical, so we can use transitivity since they're both congruent to 1, that 2 and 3 are congruent to each other. Now, this can be written in paragraph form. So here we have our 2-column proof. I want you to write down the paragraph proof as well. It's the same thing, except some people, rather than organizing it into a table, would prefer to write it out. So you still say angle 1 is congruent to angle 4 because it's given. The angle 4 is congruent to angle 2 because vertical angles are congruent. So you're basically just writing this as a sentence rather than a statement and a reason. Then by the transitive property of congruence, angle 1 is congruent to angle 2. Angle 1 is congruent to angle 3 because vertical angles are congruent. And then again by the transitive property of congruence, angle 2 is congruent to angle 3. No matter what proof you do, you end it. But be familiar with both ways. They're the same exact thing. We're stating the same information, but rather than numbering, we're putting them in complete sentences and in paragraph form. So here we have congruent supplements theorem. The theorem states that if two angles are supplements of the same angle or of congruent angles, then the two angles must be congruent. So looking at an example, if angle 1 and 3 are supplementary, and angle 2 and 3 are supplementary, then angle 1 and 2 must be congruent. So if we put numbers to it, if angle 1 was 130 degrees, and angle 3 was 130 degrees, and angle 1 was 50 degrees, 1 and 3 are supplements. That makes sense. They add up to 180. But that means that if 3 and 2 are also supplements, the only possible measure for this would be 50 degrees. So that means angle 1 and angle 2 must be congruent to each other, which we can see is the only possibility here. So let's prove this. It's given that angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. We want to prove that angle 1 is congruent to angle 2. We're going to write this as a paragraph proof. So we're going to start with the fact that 1 and 3 are supplementary and 2 and 3 are supplementary. If these are supplementary, then they must add up to 180. If 2 and 3 are supplementary, then they must add up to 180. So 1 and 3 are supplementary because it is given. So, or therefore, the measure of angle 1 plus the measure of angle 3 must equal 180 by the definition of supplementary angles. Angle 2 and angle 3 are supplementary because it's given. So the measure of angle 2 plus the measure of angle 3 must equal 180 by the same definition. Now we're going to use the transitive property of equality. Since they're both equal to 180, that means they're equal to each other. So you set it up as the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. We subtract the measure of angle 3 from both sides by the subtraction property of equality. That gives us that the measure of angle 1 equals the measure of angle 2, and then we have to change it back to congruency. So angles with the same measure are congruent. Therefore, angle 1 is congruent to angle 2, and that would be the end of our proof. We could do the same thing in two-column proof form. Angle 1 and 3 are supplementary. Reason, given. The measures equal 180. Reason, supplementary angles add up to 180. 2 and 3 are supplementary. Reason would be given. 2 plus 3 is 180 because supplementary angles add up to 180. By the transitive property, that would be your reason. You can set them equal. Subtraction property of equality, you can write it this way. And then finally, you change it back to congruency because angles with the same measure are congruent. Finally, in this chapter, we have a few more theorems. So congruent complements theorem. The first theorem states that if two angles are complements of the same angle or of congruent angles, then the two angles are congruent. Almost exactly the same as the congruent supplements theorem. So in other words, if this angle is 50 degrees and 1 and 2 are complements, then 1 must be 40 degrees. If 2 and 3 are complements, again, the only measure possible here is for it to be 40 degrees. Since 1 and 3 have equal measures, that means that they're congruent. Also, all right angles are congruent. This is something we're going to use in proofs a lot. Rather than stating that the measure is 90 and 90 is equal, there's so many more steps, but if you just state that all right angles are congruent, this can be a reason for setting angle 1 and angle 2 congruent to each other in a proof. Finally, we have if two angles are congruent and supplementary, then each is a right angle, which makes sense because if they add up to 180 and they're congruent to each other, that means their measures are equal. So the measure would be x There's two of them. They add up to 180. So x would have to equal 90 degrees for each angle. So pretty straightforward, but something that will help us in the proving process.